Hi there. In this video, we're going to demonstrate how to verify one of the ideal gas laws, in this case, Gay-Lussac's law, which states that at a constant volume, the ratio of the initial pressure, the initial temperature will be equal to the initial or final pressure and final temperature. So in order to do this, we'll be using our PASCO 850 universal interface, and attached to this is our absolute pressure temperature sensor, and we're going to be connecting this absolute zero apparatus to that. On here we have a cable for that connects to the thermistor that's inside here, and then a small tube that allows us to measure the pressure inside. So the volume inside the sphere stays constant while we're varying the temperature and pressure. So let's go ahead and connect this guy right now. Set that right there. And twist it. Oops. All right. And then with me, I have 3 different baths of water. I have a hot water over here, room temperature, and then ice water. What I'm going to be doing is we're going to be dunking the sphere inside each of these baths, letting the pressure and temperature equalize, and then recording the measurement of each water bath. So let's get started here. I'm going to open up Capstone. Well, actually, first here, let me get my screen shared here. So when you have Capstone pulled up, this is what it's going to look like when you first open it. And we're going to go ahead and select manual entry on this one because we're going to be graphing the pressure against the temperature. So we're going to go into our hardware setup. Whoops. There we go. Ensure that everything is connected. And just double check the settings. Okay. So on our x-axis, oops, come on. There we go. We want to have temperature. And let's just change this to Kelvin for the sake of calculations. And then on the y-axis, we're going to have the pressure. There we go. And let's do the same thing to our graph here. We're going to put temperature on the x-axis. And we're going to put pressure on the y-axis. Now let's open up our recording options here. So we're going to be taking measurements at certain points. So we want to use keep mode in Capstone here. So this will allow us to just keep certain data points once they've reached equilibrium inside each water bath. All right, so now that's in there, we can actually go ahead and get started here. So we'll do the hot one first and fully submerge the sphere. And keep it submerged until the pressure and temperature values have stabilized. And this may take up to 30 seconds per, possibly more. So we're just waiting for these values to stop, well, in this case, it's going to be increasing to a point to where they are just fluctuating between a range of values. Oh, still going. Still going. Okay, the pressure is fluctuating between a few. Okay, so it looks like we're good now. So we'll keep that sample. Then we'll move it over to the room temperature bath. And let this come to equilibrium. So it looks like about a minute. Give it about 1 minute to come to equilibrium. Still going down on the temperature. All right, we'll keep that one now. Now we'll move to the ice bath. And same thing. Let it come to equilibrium. And now we're still going down. Just a little bit more. All right, that's good enough. So we'll keep that one. Now we can stop. All right. So now let's do our analysis. In the table, we're going to add one more column. And in this column, we're actually going to create a calculation here using the calculator. So I'll create new calculation. Let's go into the calculator here. Actually, I guess we'll just delete both those lines. And we'll call this P over T. And this is going to be equal to the ratio of the pressure to the temperature. So we're going to click this colorful triangle. This will open up the data collection options that we have. And so we're going to select pressure first. And then we're going to divide by using a slash. And then one more time. And then select temperature. And let's change it to Kelvin. Label the units appropriately. Now we have a calculation. Before I do that, let's observe visually what we see in the graph. You can see these 3 blue dots here, a little tough to see. Should change the default color, but we're going to apply a linear curve fit. So if this law is in fact true, we should see a very linear relationship between these points. And we see actually a very strong correlation between these 3 points. So this does in fact have a very linear relationship that we're expecting. Now the next step is to verify that each of the ratios that we're going to show up in this column should be close to the same. So we're going to select measurement, and we're going to do this one here. And wouldn't you know it, they're all exactly the same. So we have effectively verified Gay-Lussac's law using Capstone software and our 850 interface.